This Delta Math topic is over probabilities with the words and or, which make a big difference when you're doing a problem. So let's take a look at our first example. There's a spinner with 15 equal areas numbered 1 through 15. If the spinner is spun one time, what's the probability? What are our chances that the result is a multiple of 3 and a multiple of 2? So when I say and, it makes a big difference compared to the word or. So it's got to be both of those things at one time. So if you imagine your spinner right there, 1 through 15, then you can think about, all right, what are all my multiples of 3? List them on your paper. You don't have to draw the spinner. Just quickly list those multiples of 3, 3, 6, 9, 12, 15. And then the multiples of 2, 2, 4, 6, 8, 10, 12, 14. And notice I underlined the 6 and the 12 because those are the only two numbers where it is a multiple of 3 and a multiple of 2. So we have two numbers off that whole spinner of 15 numbers that are going to follow our parameters. So 2 out of 15 is going to be your final result for your probability because you're always looking for your chances of the thing that you're looking for. Another example is if we have a spinner with 11 equal areas, numbered 1 through 11, and the spinner is spun just one time, what's the probability that the result is a multiple of 3 or a multiple of 2? So or is telling us to do something a little bit different. Again, imagine that spinner that you have 1 through 11, multiples of 3 and multiples of 2. List them out. Now, the difference is our number doesn't have to show up on both of them. We can list all of these numbers. We just need to make sure that we cancel out the repeats because we don't want to count number twice. So which number shows up on there twice? And it's the number 6. So we can only count it one time. So now we have 2, 3, 4, 6, 8, 9, 10. I like to go in order so I make sure I didn't miss anything, any doubles. So all together, if you count all those numbers, there are 7 of them. 7 out of 11 numbers on that spinner is going to give you a probability of 7/11. Okay. They also have a couple different probability questions on this topic. And this one says, in a certain Algebra 2 class of 22 students, now I'm going to stop right there because that wording itself is confusing for my students. Algebra 2 is a level of a math class. So it's just a class. You could say in a certain math class of 22 students, 5 of them play basketball and 11 of them play baseball. There are 3 students who play both sports, right? In real life, that happens all the time. Kids in your class might play multiple sports. Some kids don't play any sports. So we're going to actually talk about that in just a second as well. So this question says, what's the probability that a student chosen randomly from the class plays basketball or baseball? So that means you get the kids who play basketball, you get the kids who play baseball, and you get the kids who are doing both of those things, right? So you need to think about who isn't playing. And so the best thing to do, and I know you guys don't like to do this, but to make a chart, think about, okay, who doesn't play baseball, who does and doesn't play basketball. It doesn't matter which way the baseball, which way the basketball goes, but make that chart with totals at the end. So this is what that would look like, okay? You'd say, all right, this kid, he plays basketball or doesn't play basketball, or she plays baseball and doesn't play baseball, right? It just depends. So you fill in everything that you know. You've got the totals on the end there for all the kids. You're going to have total 11 that are playing baseball and a total of 5 that are playing basketball. And then you know that the ones that do both, they play baseball and basketball, they're going to overlap on our table, right? Okay. So it might not look like we have enough information, but we have enough to continue to fill in our chart. Okay. So you look for, if you have a row or a column that you have at least everything except for one number. So 3 and this number are going to be a total of 5. Well, 3 plus 2 is 5. So I can fill that in. Okay. I know that 11 plus 11 is going to give me 22. Now, how do I do it the other way? Well, I can keep going, keep filling out these totals. I could say 3 plus 8 is 11, 2 plus 9 is 11, 5 plus 17 is 22. So this is what the chart fills out or looks like when you have filled out the whole thing. And that gives you all the information you need. So it looks like a puzzle. You don't have to make a fancy chart. Just put a picture of a basketball or a picture of a baseball with the little stitches in the baseball or something really quick so that you can jot this down and just make sure that you have playing, not playing, playing, not playing with the totals at the end. Okay. So all together, you've got the people who are playing baseball or basketball is going to be 11 of those kids. Sorry, not 11. I was looking at a number 11 when I said that. 13 out of all of those kids And 13 out of 22 total in that class is going to be 13 22nds. Okay. Another way you could have approached that one on this problem a little bit quicker is you could have been like, well, back up here, 5 of them play this, 11 of them play that, and 3 of them play both. So you could just subtract out those repeats. You could be like, oh, 5 and 11 is 16. So take away those 3, it's going to be 13. So that is actually kind of a quicker way on this one, but it doesn't apply to the next one, which is the trickiest of all on this problem or on this topic. Okay, so the question is, in a certain algebra class of 28 students, okay, so similar question, 17 of them play, 9 of them, or 17 are basketball, 9 of them are baseball, and then there are 5 who play neither. Okay, 5 who play neither. So that one's a little bit trickier. We don't know how many play both. What's the probability that a student chosen randomly from the class plays both basketball and baseball? Okay, let's do the chart again. Same chart, fill out the same information. We know our total is going to be 28 students in that bottom right. Okay, we know that altogether 9 kids are playing baseball. 5 are not playing anything. So we're the one, we have the overlapping ones, the kids who play both, the one who just play one or the other, and then these kids don't play anything. Okay. I always have to get up and dance because I'm so excited about math. Okay. All right. So again, we go through and fill in what we know, like 9 plus what number is going to give me 28, or 17 plus what number is going to give me 28. And as we fill in more of those puzzle pieces, we're going to be able to fill in the rest of our chart. Because right now I wouldn't be able to fill in this column, right? I don't know if that's 8 and 1 or 7 and 2 or 5 and 4, but as I fill out, I'll figure that out. Okay, so this is what that final chart would look like, and it gives us all the information we need. So again, the question said, what's the probability this student chosen randomly from the class plays both? Okay, so these guys are playing both, right? So you have 3 out of 28, you can't simplify, and that is your final probability, 3/28.